Give you 3 seconds. Look at this question and choose which one, type your answer in the comments. Let me see your abilities. Even though we've started testing ion coexistence these past 2 years, there are still differences from previous test points. These 2 years, regardless of question type, they really like testing redox reactions, ferrous ions. Do you know? If you know, you get points. If not, no way around it. So let's look at this question, ions that can coexist in large quantities. When you see nitrate with chloride ions, it has very strong oxidizing properties. At this time, it can oxidize. Highly reducible iodide ions and ferrous ions, I emphasize again, nitrate can oxidize both of them, but cannot oxidize chloride ions, permanganate. Ions can oxidize chloride ions. Remember this conclusion well. Don't get confused now. First option, you say, teacher, this reaction seems like we haven't learned it, so I don't know if they coexist. Remember ferrous ions. What do we use to test ferrous ions? Don't we use potassium ferricyanide? The ferricyanide ion is complex, isn't it? So these 2 ions together will produce it undergo redox reaction. Therefore, they don't coexist for reference. For example, ferric ions, would they react with sulfide ions? We test ferric ions using potassium sulfide. After reaction, it produces potassium sulfide. This is the equation in our textbook, but in our practice, we discover actually the coordination numbers here can be from 1 to 6. This is what the textbook gives. Next time, if it's written for you, if sulfide ions with 4 mod 2 react, how should this equation be written? Students, look carefully. Don't we use 4? Then write sulfide as -1, ion as +3. The whole thing needs a unit charge. Writing the ion like this works. So this is the power symbol from the textbook. Let's follow the textbook. Okay, this deserves attention because I think it will definitely be tested this year. Next one, calcium silicate precipitates, so it can't coexist in large quantities. This question allows multiple choices, I said. Teacher, it's a weak cation. Both are weak anions. They promote hydrolysis with each other, so they can't coexist in large quantities. Well, students, our course repeatedly emphasizes for complete double hydrolysis to occur. They can't coexist in large quantities. How can thorough double hydrolysis happen? Top supplements, bottom leaks. One forms precipitate, one forms gas. They must leave the system to continuously promote each other. Or both form precipitates, leave the solution system to promote hydrolysis with each other. But they, at this time, form acetate or carbonate by route. They form acetic acid or carbonic acid. Their solubility is relatively high. Then they react back again, becoming acetate, becoming carbonate chloride. Therefore, they can coexist in large quantities. Remember this conclusion well. Use the teaching memory method too. Any other questions? Fan group.